Hello everyone, welcome back to Higher Maths. Today we're back on Recurrence Relations, second lesson. We're going to try and use the recurrence relation to find the next couple of terms, or if we're given a term like U3, go backwards and try and figure out U2 or U1. Okay, so remember the basics from last time. This is how we write out a recurrence relation. This is the notation that we use. UN add 1 equals 0.25 UN plus 6, and we're told that U0, the initial value, is 100. Remember, to get the next term, you need to use the last term. To get U1, we need to use U0. To get U2, we have to use U1, and so on. Part A. Calculate the value of U3. You can see that they've given us U0. Now, last time I told you the fast method of doing this on your calculator. It will save us a lot of time and a lot of hassle. So let's look at the fast method. To do the fast method, on your scientific calculator, you press 100, hit equals, then times by 0.25, add 6, and hit equals. It will then tell you that U1 is 31. If you then hit equals, it will tell you what U2 is. You don't need to do any more work. The clever calculator knows everything for you. And part A wants us to get U3, so I'm going to hit equals again, and U3 is 9 7/16. I could change it to a decimal if I wanted to, but I'm just going to leave it as the fraction answer. Now part B, find the smallest value of n for which UN is less than 9. So this is asking us to keep the recurrence relation going until you get an answer smaller than 9. We're almost there. We're at 9 7/16. So I'm going to hit equals again on my calculator and see what the next answer is going to be. If I do that, U4 gives me an answer of 8 23/64. Okay, so the smallest value of n for which the recurrence relation is less than 9 is going to be 4. 4 is the first answer that takes us under 9. Okay? Right, let's look at another example. Same idea, different recurrence relation this time. We have UN add 1 equals 0.6 UN add 5, and we're told that U0 equals 8. Part A, calculate the value of U2. So U0 is 8. U1, again I'll use my calculator for this. So if you're all ready, hit 8, which is the initial value, then hit equals, then times by 0.6 plus 5, hit equals. You should get 9 4/5. It wants U2, so I just hit equals on my calculator, and I get U2. Again, I'm just going to keep my answer as a fraction to save any rounding. Part B this time, find the smallest value of n for which UN is greater than 12. It is asking you to keep this going until you get an answer bigger than 12. So I'm going to hit equals on my calculator again. U3 is 11 66/125. I'm going, that's not bigger than 12 yet. Need to hit equals again. If I hit equals again, it's 11, and check this fraction out. So I'm not bigger than 12 yet. I need to hit equals again, and if I hit equals again, I do get bigger than 12. I get a real big horrible fraction. This time I'm going to write it as a decimal because the fraction is just too horrible. I get 12.15. So the smallest value of n for which UN is greater than 12, the first of our answers which goes above 12, is 5. So my answer is n equals 5. So all the time here I'm using the last answer to get the next answer. That's a really important thing. Now, if you're thinking things are quite easy, let's throw in something a little bit different. A sequence is defined by the recurrence relation UN add 1 equals x UN plus 3, where U0 equals 4. find u2 in terms of x. Okay, so far we've been used to a number being in here. This time we've got an x. Now what does that mean to our answer? It means that our answer won't be 10 or 12 or 15. Our answer will contain the letter x. That's what it says. Find u2 in terms of x. Your answer for u2 will include x. So there's no cheats way of doing this one. We're going to have to do it properly. So u0 is 4. To get u1, I'm going to substitute 4 in instead of un. So I'd get x times 4, or I'd get 4x plus 3. Remember, your answer will include the letter x. We're not going to get a normal number answer here because of this x thing up here. To get u2, I need to use my previous answer. I need to substitute that instead of the un. If I do that, I'm going to get x, then this. So I'm going to get x multiplied by, so get a bracket in, 4x add 3, and I've still got the add 3 at the end. Multiply at the bracket, job done. Find u2 in terms of x. I have done that. There is my answer for u2. Remember, to get the next answer you've got to use your last answer. So when I had 4 as my first answer, I had to substitute that back in instead of un, and that will give me my next answer. u1, the answer was 4x add 3. To get the next answer, u2, that needed substituted in instead of un as well. Right, next example. This time we're going to go backwards. A sequence is defined by the recurrence relation un add 1 equals 0.75 un take away 2. Given u2 equals 10, find u0. Right, so far we've always been going up the way. Get u0, u1, u2, u3 and so on. Now we're going back the way. So we've been given u2. The first thing I can do is I can work out what u1 is going to be. Now remember, in your recurrence relation, this answer would be here. 10 would equal 0.75 times u1 minus 2. Okay, have a wee think about what I did there. Usually we would use the answer for u1 to get u2, but this time we're going backwards. We know the answer for u2, so we're using that in here to find out the answer for u1. I've got a little equation here that I need to solve. I need to get u1 by itself. So I'm going to add 2 to both sides. So 12 will equal 0.75 times u1. And now I'm going to try and get the u1 by itself. So I need to get rid of the 0.75. It's multiplying. Take it to the other side. It's going to be dividing. I'm just going to switch this round as well. I'm going to put u1 equals, take the 0.75 to the other side, and I'm going to get 12 divided by 0.75, and that's going to give me an answer of 16. That's u1. The question wanted u0. So now I'm going to have to do the whole thing again, starting with 16. So my recurrence relation is un add 1 equals 0.75 un take away 2. Now I'm going to use u1 as my answer, and I'm going to use u0 in the recurrence relation, and I'll let you see what I'm doing. Okay, so what I've done here, this is u1 and it would go with u0. I'm always using the last answer to get the next answer, but this one is done in reverse. So I'm going to have to add 2 to both sides again. 18 is going to equal 0.75 u0. Take that to the other side, it's going to be dividing. u0 is going to be 18 divided by 0.75. and that works out to be 24. That one might take a little bit of time to get used to. We've been so used to going up the way, U0, U1, U2, U3, switching that around and going backwards takes a little bit of thinking about. Okay, time for you to do some work. So here's your first one. A sequence is defined by the recurrence relation UN add 1 equals 1.5 UN add 10, where U0 equals 100. Part A, calculate the value of U4. Part B, find the smallest value of n for which UN is greater than 1000. And part C, how many terms of this sequence lie between 1000 and 2000. So how many answers are between 1000 and 2000. So hit pause, off you go. Right, how was that? Part A, U0 equals 100. Using the fast method, using my calculator, so hit 100, hit equals, times by 1.5, add 10, hit equals. My next answer for U1 is 160. Hit equals, U2 is 250, and I hit the wrong button, so I shall have to do this again. Always important to hit the right button, people. If you hit the wrong button, you'll get the wrong answer. Okay, U3, back in the game, is 385. U4, 587.5. Let's go with 0.5 this time rather than a half. Let's just keep you on your toes. Okay, part B. Find the smallest value of n for which UN is greater than 1000. So I just need to use my calculator and hit my calculator, hit equals, and work my way through until I get the first answer, which is bigger than 1000. U5 is 891 and a quarter, and then U6 is 1346 and 7/8. So that is the first answer that takes me over 1000, so n will equal 6. Part C wants how many terms lie between 1000 and 2000. Well, I've already got one, this answer here. Hit equals on my calculator again. U7 is already over 2000. So the answer is one term. Okay. Next one. A sequence is defined by the recurrence relation UN add 1 equals 0.75 UN add 4, where U0 equals 20. Part A, calculate the value of U2. Part B, what is the smallest value of n for which UN is less than 17? Okay, hit pause, off you go. Okay, using the calculator, using the fast method, U0 is 20, U1 is 19, U2 is 18 and a quarter. Job done. What is the smallest value of n for which UN is less than 17? So what is the first one that's going to give you an answer less than 17? Well, U3 is 17 and 11/16. U4 is 17 and 17/64, and U5 takes us into the 16s. So the first one, the smallest value of n equals 5. Finished. Easy peasy. See, who said higher maths is going to be difficult? Right, last one. I just thought I'd give you another one. Right, a sequence is defined by the recurrence relation UN add 1 equals 0.5 UN add 2. Given U2 equals 5.5, find U0. So the hardest type, in my humble opinion, the ones where you've got to go backwards. If you need to go back in the video and have a look at what I did, do that. This isn't a test, remember, and then see if you can answer this question. Okay, I'm going to get U2. That means I can use that answer to get U1. So my recurrence relation, there's my answer, this is U2. And I can use this to get U1. So I'm going to have to balance this equation, so I'm going to take 2 off both sides. 3.5 is going to equal 0.5 U1. I'm going to take the 0.5 to the other side, it will become a divide. I'll just switch it round anyway. And that's going to give me an answer of 7 for U1. I'm going to do the exact same again to try and get the answer for U0. So 7 is going to equal 0.5 times U0 add 2. So there's my recurrence relation. I'm going to balance it, take 2 off both sides. 5 will equal 0.5 times U0. Take the 0.5 to the other side where it will be a divide. U0 is going to be 5 divided by 0.5, which works out to be 10. Full marks, anybody? Good stuff. Today's lesson is now over.